Okay, second part of conditions for parallelograms here. I want to do a couple quick proofs on the last three things. Okay, so if both pairs of opposite sides are congruent, we can say that the shape is a parallelogram. I'm going to show you here on GeoGebra why that's the case. Okay, so we're here on GeoGebra, and I drew up a quadrilateral. You see the opposite sides are different. Okay, so I want to try to move these things around to where the opposite sides are equal to each other. So I'm going to sort of do that here. I'm going to try to make this side here 5.5 and the other side 6.6. So these things match up here. Okay. Now, a little hard to see, but again, parallel means lines have the same slope. Okay. So pause the video, calculate the slope from D to B and C to A, like we did on the back of 8A, and calculate the slope from C to D and A to B here. Okay. We see their distances match up here and here and here and here. And you should see that the slopes match up too. If you want to create your own shape on GeoGebra, you can, and match up the opposite sides in terms of their distance, and you'll see that their slopes are going to match up as well, forcing the sides to be parallel. Okay, so that's the first part of that. So if both pairs of opposite sides are congruent, we prove there that it's going to force the opposite sides to be parallel. It's going to be a parallelogram. Okay, next. If I have diagonals that bisect each other, if diagonals bisect each other, they have the same midpoint, okay? So I'm going to draw two lines that have the same midpoint. I'm just going to make the midpoint here -4, 0 for nice and simple simplicity, okay? So if I'm at -4, 0 here, let's say I have this is a midpoint. So I'm going to go 1 point. I'm going to put it at -1, 2 here, all right? So this goes up by 2 over by 3, so I'm going to go down by 2 over by 3. So here's one diagonal right here. It has a midpoint -4, 0. Okay, I'm going to do another diagonal with this midpoint here. I'm going to go down by let's go down by 5. 1, 2, 3, 4, 5, and over by 1. So now I'm going to go up by 5. 1, 2, 3, 4, 5, and over by 1. So now I can draw up a parallelogram connecting these points here and these points here. I forgot my blue diagonal here. So the diagonals bisect each other. They bisect each other. They have the same midpoint. Okay. So now I know my points are a little sloppy. I can calculate the slope of the opposite sides here and the slope of the opposite sides there. And I should be able to see that the opposite sides have the same slope, making the opposite sides parallel as well. Okay. So just draw two lines that have the same midpoint. Those will be your diagonals. Connect the corners. Okay. Last one, if I have one pair of sides that's congruent and parallel, we're going to go back to GeoGebra for that. Okay. So right here, I have this side AB, and draw a line between a segment between A and B. And we see AB has a slope of -2, 4, goes down by 2 over by 4. Well, CD does the same thing, down by 2 over by 4. Okay. So we see those lines are parallel. I'm going to calculate the distance. That distance 4.5. That distance is 4.5. So these two lines are parallel and congruent. Well, what's going to happen here is all I need to prove is that the other two lines are parallel to each other. Okay. So C to A and D to B. So C, I go up by 1, 2, 3, 4, and I go over 1, 2, 3, 4, 5, 6. So this has a slope of 4 over 6. This one, 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. So this is going to be a parallelogram as well, only knowing that CD and AB are parallel and congruent. Okay, since they're parallel and congruent, it forces those two sides to be parallel. So that sort of explains our last three proofs on 8A. So we should be able to mark yes or no on these, whether these are parallelograms or not, based on our 4 highlighted conditions up here for parallelograms. So if there's any questions, please don't hesitate to ask, and that should help you get finished with our 8A notes. Thank you.